Good day! Welcome to the third quarter, and our first lesson is the exponential function. Yung gusto nating ma-accomplish today ay 1. Ma-define natin kung ano ba ang exponential function. Siguro evaluate natin yung isang exponential function para makita natin how it behaves. And we have an idea how to sketch the graph. And then, based on the graph, based on the values nung in-evaluate natin exponential function, we could describe yung properties nung function na yun. So, domain, yung range, meron ba siyang asymptotes, ano ba yung intercepts niya, and so on and so forth. It is unfortunate no, that we are living in a time of pandemic, which means na yung gagamitin nating information at data sa examples natin sa exponential function, based sila sa reality. Dati kasi, when we used exponential functions and apply it to the spread of diseases, to pandemics, nasa theoretical sila, or we're using data from other countries na ibang panahon. What I have here is data from the United States. Hindi ako nakakuha ng data on the Philippines agad-agad at na-plot ng ganito. But this data of the total number of coronavirus cases in that country over a course of 1 month, makikita natin na from Feb 15 halos wala, zero, mababa. For several days parang walang nangyayari, pero parang unti-unting tumataas. Then at some point, yung rate ng pag-increase niya, medyo dramatic na, ang bilis na. Like between March 10 to March 14 over a course of 4 days. It's almost 3,000 cases na increase. Now, of course, we know ngayon, they're breaking records every day with their number of cases. So, it's much further up than that. And sadly, this sort of distribution, this can be described by an exponential function. Now, exponential functions lend themselves very well sa pag-model ng spread ng diseases, spread ng pandemics, among other things. And in this case, hindi natin gusto no, na mag-boost up yung number of diseases. So parang we make a model kung ano mangyayari pag hindi natin or pag wala tayong ginagawang steps to prevent the spread of disease. And then compare yung projections natin na if we do isolation, in this case sa graph na to, isolation yung intervention na pinaplot against yung control, yung walang interventions na ginagawa, and the hope that ma-arrest yung sudden increase in cases na ibibigay ng isang exponential function. It's important to note no, that hindi lang naman exponential functions yung ginagamit natin pang model sa mga biological spread. So there are other models, and one of the most used models is yung SIR, the susceptible, infected, and recovered or removed na model, which takes into account na nagiging immune na, so bumababa yung total population. On a lighter note, another phenomenon that can be modeled by exponential functions ay yung pagdampen ng bounces ng isang bouncing ball. So what we're looking at here is yung height nung pinanggagalingan ng bola as it bounces. So yung maximum height bababa sa third bounce, then bababa dun sa fourth bounce. And if we connect the dots ng mga peaks ng mga bounces, para siyang ma-approximate ng isang exponential function until it flattens out. So in terms of applications, yung exponential functions yung isa sa mga mabilis mahanapan ng pwedeng paggamitan sa real-world context. So this is widely used in biology, in chemistry, lalo na sa physics. And this is also widely used sa investments, sa pag-track ng values ng mga bagay sa finance, and so on. So let's go in dun sa mathematics niya. Define na natin siya. An exponential function is of this form, y equals b raised to x, where b is a real number, pero kailangan positive siya. Hindi pwedeng 0, hindi pwedeng negative. Tapos, hindi rin natin gagamitin yung b equals 1. So, b is greater than 0, and b is not equal to 1. So, why are these restrictions important? So, let's break yung restrictions. Sige natin kung ano mangyayari. So, kunyari, b is negative 2. So, hindi pwede yun. Ano ba mangyayari pag b is negative 2? So, if b is negative 2, then yung b raised to 1 half, magiging square root of negative 2. And square root of negative 2 is an imaginary number. So, hindi na tayo makakahanap ng real value for y. So, hindi natin siya isasama sa possible values nung b na pwede natin gamitin. By the way, yung b na yan, it stands for base. Call this the base, and this is the exponent. So the base cannot be negative kasi magpupunta tayo sa mundo na meron tayong mga imaginary numbers at hindi natin siya mapaplot. If b is equal to 1, then magiging sobra naman yung trivial. 1 raised to any exponent is equal to 1. So we're not including that kasi it's just a constant function, y equals 1. And finally, if p is 0, b is 0. 0 raised to a non-zero exponent will be equal to 0. So, medyo magiging trivial na naman siya. And then, pag ginawa mo namang 0 yung x, 0 raised to 0, ano yun? Is it equal to 0? Is it equal to 1? Kasi 0 raised to an exponent is 0, but any number raised to 0 is 1. So, may dalawang rules na magko-conflict. So, we're not sure. So, actually, we say that 0 raised to 0 is an indefinite form. So those are the reasons for the restrictions. So again, kailangan positive at hindi equal to 1. Pwedeng less than 1, basta positive siya. Let's graph an exponential function. Let's say our function is 2 raised to x. Ang base natin ay 2. And these are our x values na gagamitin pang plot. So 2 raised to negative 4 is 1 over 16. So here is our point. 2 raised to negative 3 is 1 over 8. 2 raised to negative 1 half is 1/4. 2 raised to negative 1 is 1 half. 2 raised to 0 is 1. 2 raised to 1 is 2. 2 squared is 4. 2 cubed is 8. And 2 to the 4th is 16. So this is our graph of an exponential function na ang base natin ay 2. Now, let's take a look at this function and try to identify some properties na pwede nating ma-identify looking at this sketch. So first, meron ba tayong x value na hindi pwedeng gamitin, na magiging undefined yung expression natin? So, dapat wala. Kasi, if x is a negative number, okay lang yan. Alam natin yung gagawin. That is the reciprocal of 2 raised to kung ano man yung positive value ng exponent. Kung integer yung x, alam natin yung gagawin. It's like repeated multiplication. So, let's say x is equal to 4. So, it's 2 times 2 times 2 times 2. Kung 0 naman siya, we know that 2 to the 0 is 1. So, we could plot that. If it's a negative integer, kunyari, negative 3, is the same as 1 over 2 cubed. So, makukuha natin siya na 1 over 8. Kung fraction siya, kunyari, 1/3, 1/4, 2 raised to 1/3, alam natin na ano yun? Cube root. 2 raised to 1/4, alam natin na 4th root. So, we know what to do pag ang x natin ay 1 over an integer. Kung fraction naman siya na hindi 1 over something, kunyari 2 raised to 4/3, then we know that is 2 raised to 4, then kukunin natin yung cube root. So may value pa rin tayo. So at this point, ang hindi natin alam kung ano yung gagawin ay pag 2 raised to an irrational number. What is 2 raised to square root of 2? Well, wala tayong description for that right now. But square root of 2 is approximately 1.414 something. So, pwede natin siyang i-approximate na 2 raised to 1.41, which is a rational number. Pwede mong gawing 141 over 100. So, you know what to do with that. 100th root, tapos raise mo to 141. And then, 2 raised to 1.42. So, yung 2 raised to square root of 2, it's somewhere in between 2 raised to 1.41 and 2 raised to 1.42. So, even if we don't know exactly what to do para makuha yung 2 raised to square root of 2, we know we could find kung nasan siya banda. And we could find maybe 2 rational numbers close enough na we could use that to approximate kung ano ang 2 raised to square root of 2. Kahit di natin alam sa ngayon kung paano i-evaluate yun. So, what's my point there? My point is, lahat ng x values pwede natin gamitin. The domain is the set of real numbers. Pwede bang maging 0 yung expression na to? Well, meron kang 2 eh. 2 raised to something. If that's something, if x is positive, then mas malaki siya sa 2. Pwede ba siyang maging 0? Hindi, kasi you have a number, a positive number, being raised to something. So it's either going to be very big or very small. Pero the only way you'll get a 0 for that is if you multiply it by 0. Even if x is something very, very small, kunyari, negative 1 million. So magiging 1 over 2 raised to 1 million. That's still positive. So hindi siya pwedeng maging 0. Pwede ba siyang maging negative? Well, hindi rin. Kasi positive number siya eh. And you're raising it to an exponent. So, the range is y is greater than 0, or the set of positive real numbers. Y-intercept. The y-intercept is the value of the function when x is 0. So, 2 raised to 0, that will be equal to 1. Actually, kahit anong base yung ipalit mo dyan na pwede, if x is 0, then that expression will always be equal to 1. So, yung y-intercept na 1 is actually the y-intercept of all exponential functions of the form y equals b raised to x. Next, our function is continuous. Wala siyang holes, wala siyang discontinuities. Kasi lahat ng x, lahat ng x values pwede nating gamitin. And lahat ng x values may consequent na y value if we raise 2 to that value. So, wala tayong mga butas. It is 1-to-1. It will pass the horizontal line test. And it also means na unique lahat ng y values for each unique x value na gagamitin natin. So, walang uulit na y value for different values of x. Hindi pwedeng 2 raised to a is equal to 2 raised to b, pero hindi equal si a and b. It is increasing. That much is obvious. And finally, related dun sa range natin ay y is greater than 0, meron siyang horizontal asymptote, which is the x-axis. And it approaches the x-axis as x approaches negative infinity, or pag pupunta tayo sa papalaking negative values. Why does that make sense? So, kunyari, x is negative 1 million nga. That will be 1 over 2 raised to 1 million. That will be a very, very small number, but that's not equal to 0. But it's very, very close to 0. So, it will behave asymptotically with respect to the x-axis. Okay, here I superimpose 3 exponential functions. Y equals 2 to the x, y equals 3 to the x, and y equals 4 to the x. Notice that first, lahat sila may y-intercept na equals to 1. Kasi if x is 0, then all of these values will be equal to 1. When x is positive, mas mabilis yung pag-increase ng value ng 4 to the x sa 3 to the x at sa 2 to the x. So when x is equal to 1, si 2 to the x nasa 2 pa lang. Si 3 to the x nasa 3 na at si 4 to the x nasa 4. And when x equals 2, yung blue nasa 4, yung orange 3 to the x nasa 9, yung pink or 4 squared nasa 16 na. So pag mas malaki yung b mo, it increases faster when x is positive. But the behavior is different when x is negative. When x is negative, mas mataas yung value nung mas maliit yung base. At mas mababa yung value nung mas malaki yung base. And that should make sense kasi negative yung x eh. So parang mag-reciprocal siya. So if x is 10, mas mataas ang 1 over 2 raised to 10 sa 1 over 4 raised to 10. Yung mas matataas na values nagpapalit pag nagpunta na yung x values natin from negative to positive. I want to talk about the natural exponential function quickly. So if you look at your calculators, may makita kayo minsan na function na e raised to x or yung letter na e. E stands for Euler. This is what we call Euler's number. Marami siyang definition. And yung una siguro nating ma-encounter na definition sa kanya for grade 9 is it's the limit of 1 plus 1 over n raised to n as n approaches infinity. Ibig sabihin nun, pag pinalaki mo ng pinalaki yung n dito, so liliit ito, no? Parang 1 plus 1 to the n. Pero nire-raise mo siya to a power n. Habang papalapit ng infinity yung n mo, yung value nitong fraction na to, na nire-raise mo sa exponent, papalapit sa 2.71828, 1828, and so on. This is an irrational number. So, hindi siya magre-repeat, hindi siya ma-express as a fraction. Although, madali siyang tandaan up to 10 decimal places kasi ang kailangan natin tandaan ay 2.71828 kasi ulit na naman yung 1828. Pero after that wala nang uulit na pattern na madaling tandaan. And since E is between 2 and 3, yung e to the x, yung graph niya, it's also between 2 to the x and 3 to the x. We will encounter this more often siguro in the future math lessons, pero i-introduce natin siya ngayon. And I just want to show what makes this special na may sarili siyang pangalan at may sarili siyang button sa calculators natin. Okay, so here I open GeoGebra. Tapos pinlot ko yung graph ng f of x equals e raised to x. So, ito yun. Siyempre, dadaan siya ng 0, 1. So, I have a slider and the point P na ang coordinates ay yung value ng slider, A, tsaka yung function evaluated at A, or e raised to A. So, when I do my slider thing, sinusundan ko lang yung graph, yung sketch ng graph ng exponential function natin. Now, what makes e special as it refers to exponential function is that if we plot yung tangent line, meaning it's the line na nagtatouch lang dun sa curve at one point, yung slope nung line na yon. So, m, here I have g equals y equals mx plus b. Ito yung b. Ito yung m na slope. Yung slope nung line natin, nung tangent line natin, parehong-pareho siya dun sa y value nung point na tinatouch niya. And this is only true for e raised to x. So, yung implication na slope ng tangent line ay pareho dun sa function value, that will be discovered pagdating natin ng Math 5 kung bakit siya important. For now, ang alam lang natin, special si e raised to x kasi yung tangent line to a point on the curve, yung slope nun, pareho dun sa y value nung point dun sa curve natin na yun. Let's continue on to transformations ng exponential function. So, as with any function, yung rules natin sa transformations na na-discuss natin before, they will apply. So now, I'm opening up Desmos and I'm graphing y equals 2 raised to x. We want to make a reflection along the y-axis. So we know that when we want to reflect our function along the y-axis, papalitan natin yung x ng negative x. So plot natin y raised to negative x. And we'll have a reflection along the y-axis. But here's what's interesting sa reflection along the y-axis sa exponential function. Tignan natin siya. Y equals 2 raised to negative x. Hindi ba yan pareho lang sa y equals 2 raised to negative 1 times x? It's the same graph. The green and the purple. Oops. Green and the purple. They're the same graph. Pareho lang siya. At yung 2 raised to negative 1 times x, pwede natin siyang sulat na y equals 1 half raised to x. Again, it's the same graph. See the overlaps. Even if I hide this, hide. They're the same graph. And itong y equals 1 half raised to x. This is an exponential function na ang base natin ay 1 half. Same rules apply. If we replace x with negative x, then it will reflect along the y-axis. But interestingly, yung reflection na yun, makukuha din natin yun by taking the reciprocal of the base. Kasi replacing x with negative x in an exponential function is equivalent to taking the reciprocal of the base. We also talk about yung reflection ng exponential function along the x-axis. It's the same rule as with the other functions we discussed before. We will just multiply negative 1 to the entire function para makuha yung reflection niya along the x-axis or inenegate lang natin siya. Nothing surprising there. To translate an exponential function, we follow the same rule that we use pag nagtatranslate tayo ng functions natin before, yung mga polynomials. So here, we have our exponential function y equals 2 raised to x. And we know na kung gagawa tayo ng translation, mag-a-add lang tayo ng constant after the function. So here, I added a slider. I would set ko muna siya to 0. And I would take note na meron tayong horizontal asymptote na y equals 0. And since d is equal to 0, then I'll call it y equals d. And by adding a positive number dun sa function natin na 2 raised to x, let's say I added 3. Then, nagkaroon tayo ng vertical translation na pataas na 3 units. And that takes everything up ng 3 units, including the horizontal asymptote. If we add, let's say, negative 1, so this is a translation of 1 unit downwards sa function natin, and that includes yung horizontal asymptote. Bababa din siya ng 1 unit. So in a sense, we could say that the horizontal asymptote is y equals d, where d is the constant na ina-add natin dun sa dulo ng function natin. Balik natin itong 0. If we want to do a horizontal translation, to help us visualize yung translation, let's plot a point. And to do that, yung y gagawin ko na lang siyang f of x. And magpa-plot tayo ng point c f of c. Okay, so we know that we'll have a horizontal translation if we replace x with x minus c. And if c is positive, is it to the left or to the right movement natin? So x minus positive. So if c is equal to 2, nag-move tayo ng 2 units to the right. And if c is negative, so x plus 1, kasi c is equal to negative 1, then that's a 1 unit move. So it's the same. And we talked about translations with our other functions before. So to summarize, pag nag-add tayo ng positive na constant sa labas ng function, that's a vertical translation upwards. If it's negative, then it's vertical translation downwards. Pag pinalitan natin yung x ng x minus c, at yung c ay positive, it's a translation to the right. And if c is negative, then it's a translation to the left. And you can combine translations, both horizontal and vertical, para magkaroon ng oblique na translation. And finally, we could apply a vertical scaling dun sa function natin. So we could do that by setting a multiplier na constant sa unahan ng exponential function natin. So, kunyari, a. So I placed a in front of f to scale vertically yung function natin. So if I change a to 3, we multiply everything by 3 dun sa 2 to the x, it scales our function vertically by 3. And yung ating y-intercept from 1, aakit siya ng 3. If a is equal to 5, yung y-intercept natin is 5. If a is less than 1, so it scales down our function. And ang y-intercept natin ay 0.3. And if a is negative, then magkakaroon ka lang ng additional na reflection along the x-axis. And your y-intercept will be at negative 1.6. So again, it's not much different when we multiply functions from before by a constant. Magkakaroon siya ng vertical scaling, and if it's negative, may additional na reflection along the x-axis. So that's it muna for our introduction to exponential functions. Sa next week, we'll talk about yung inverse naman ng exponential function. And then later, we'll combine those two concepts para mag-solve ng equations. So thank you very much, and I'll see you sa next lesson natin.